Good morning and welcome to all. My name is Dharmesh Gandhi, and I'm EY Canada's Quantitative Services Leader for the Central Region. Thank you all for joining us here at EY for today's lecture, Power and Prediction, the Disruptive Economics of Artificial Intelligence with Professor Ajay Agrawal. We are really excited to host this event for a long-standing partner, Next Canada. EY has been with Next since day one, and we are honored to work with them to build a critical mass of best-in-class startups who are solving real-world problems and enhancing the lives of Canadians and communities from coast to coast. As an extension of our relationship, we are pleased to partner with Next on this event and host you for this thought-provoking lecture on the proliferation of AI. In preparation for today's lecture, I actually went back to Prediction Machines, one of Ajay's previous books. One example that stuck out discusses the impact of greater access to cheap AI was having on language translation and how it was transforming communication through the use of contextual language. The forward-looking nature of this commentary was exemplified this year, actually, with one of the Next 36 companies, A View, which is focused on using the power of AI to auto-transcribe, translate, and post content from the most popular content creators internationally. Logan Paul, Mr. Beast, all of that's done in English. They're going to take it and make it in Hindi and Chinese and Mandarin, Cantonese, all of those different languages. It's really fun when you see something that's written about in a book come to life and kind of become a reality. In Power and Prediction, Professor Agrawal, with his colleagues, Professor Avi Goldfarb and Professor Joshua Gans, bring you insights into the second wave of artificial intelligence. In the first wave, AI was widely hyped but narrowly focused. Fraud detection for banking, chatbots for customer service. Next, best actions for sales and marketing. Now the second wave is coming. The hype has diminished, but the impact is amplified. These applications will not simply enhance productivity, they will disrupt industries and shift the balance of power among companies and nations. And just like the last book, I really look forward to hearing on how to approach the second wave and how our organizations can capitalize on the opportunities that it presents. I'd also like to acknowledge that this lecture is presented as a part of the Next Canada Academic Excellence Fund, which is generously supported by the Hilary and Galen Weston Foundation. The Weston family have been steadfast supporters of Next since day one, with W. Galen Weston being one of 3 founding patrons of the organization. And I think that's actually worth a round of applause. With that, I'm pleased to introduce you to a special guest we have here today to introduce Ajay. I'd like to welcome Cheryl Song to the podium. Cheryl is co-founder and CEO of Reina, a co-living and apartment rental platform that leverages technology to make renting and living easier for the new generation of renters. Prior to founding Reina, Cheryl specialized in executive search, talent strategy, leadership succession, and board services in the commercial real estate sector across North America and Asia. She's also the chair of the board for Street Haven, the oldest women's shelter in Toronto. During her time at Next Canada, Cheryl won a lot of awards. Cheryl was recipient of the W. Galen Weston Top Entrepreneur Award, as well as the EY Women in Tech Award. She was also named as the Peaks 2022 Emerging Leader for Startups in Tech. Before I pass the mic over to Cheryl, I'd like to congratulate her and her co-founder, Katie Diao, for landing a deal on Dragon's Den worth $1 million with Robert Herjavec. On behalf of UI, congratulations, Cheryl. We look forward to watching you and Reina hit new heights for the years to come.
Well, thank you so much, Dharmesh. It's my pleasure to be here. And when I was initially asked for the opportunity to introduce Ajay, I absolutely jumped on it. Because all of the accolades that Dharmesh just mentioned, we couldn't have achieved without the support of Next Canada. So we joined the Next Founders Program in March 2021. That was 2 months after we launched Reina. And just like any young entrepreneurs, I was hungry, I was eager. I thought I would set out for world domination. Or so I thought. Within 15 minutes of meeting Professor Akbar, and I think many of you here probably have had a similar experience. So Professor Agrawal closed his eyes, leaned back, and he paused for a second. And then he said something so profoundly inspiring that made me realize I wasn't remotely thinking big enough. And that really changed the direction of our company. It made us realize the unimaginable is in fact achievable. So it is my privilege to introduce you to someone who has greatly impacted my career as an entrepreneur. Professor Ajay Agrawal is an economist and professor at the University of Toronto's Rowman School of Management. He conducts research on the economics of innovation and serves on the editorial board of Management Science. He has published over 70 peer-reviewed articles, as well as co-authored 2 books on Harvard Business Press, Prediction Machine, The Simple Economics of Artificial Intelligence, and Power and Prediction, The Disruptive Economics of Artificial Intelligence. He is the founder of the Creative Destruction Lab and the co-founder of Next Canada, both non-for-profit programs that supports the commercialization of science via entrepreneurship. He is a research associate at the National Bureau of Economic Research in Cambridge, Massachusetts, and academic advisory council member at the Center of Regulation and Markets at Brookings in Washington, D.C., and advisory board member at the Carnegie Mellon University's Block Center for Technology and Society in Pittsburgh, and a faculty affiliate at the Vector Institute for Artificial Intelligence in Toronto. He is founder of Metaverse Mind Lab, building enterprise AI solution for the metaverse. He is co-founder of Sanctuary, creating the world's first human-like intelligence in human robots. The Globe and Mail listed Professor Akbar as one of the 50 most powerful people in Canadian business. He was appointed as a member of the Order of Canada in 2022. Wow, it's kind of hard to imagine one person can accomplish all of these things. I'm getting sweaty just reading this. Professor Akbar, it is my pleasure to welcome you to the podium.
Thanks, Cheryl. Okay, well, thanks very much, Cheryl. That's a wonderful introduction. And thank you, everybody, for coming in the middle of the afternoon to hear about the work that we've been doing on economics and machine intelligence. And it's just wonderful to see so many people who, we've been watching over the years, building your businesses and also partners of Next, coming to hear about this work. So I'm going to just sort of summarize. The book has a bunch of different points in it, and I've picked 3 that I think will be salient for this group. So the first one, and really what I would view as the main theme of the book, is that the next wave of AI solutions are going to be what we call system solutions as opposed to point solutions. And so most of what we've seen so far, including most companies, for example, in Next AI, have been point solutions. And those are very important, and there's a lot of great business opportunities associated with point solutions. Some of those point solutions, I think, can be converted into system solutions. Reina is one of them, Cheryl's business. You'll see why in a few moments. Okay, so just a quick reminder, thank you for bringing up prediction machines. And just before I begin that, how many people have filed a shred credit here? Okay, so there's a lot of customers in the room. And for those of you who haven't yet filed one, make sure you talk to the people who do, because they will tell you to make sure all your books are in order and your accounting for what people are working on is well recorded in advance, because otherwise these shred filings are a nightmare. But if they're done properly, it's a big advantage to being in Canada. Okay, so very quick primer. a few highlights of what was in prediction machines, because that lays the groundwork for what we then go on to do in the new book. So the essence of prediction machines is the point that from an economics perspective, as opposed to, let's say, a computer science or electrical engineering or statistics perspective, how economists think about all technology is we reduce every technology, AI, as well as anything else. Always the economist trick is the same, which is take the technology and simplify it down to a single question. And the question is, what does this reduce the cost of? So in the case of semiconductors, economists studied that for a while. Okay, we get it. Semiconductors lowers the cost of arithmetic. Internet, study it for a while. Economists eventually say, okay, we get it. Lowers the cost of communication, lowers the cost of search, lowers the cost of distribution of digital goods and services. If you ask computer scientists, can you tell me about what's happened over the last decade in AI? They will probably have an image like this in the back of their mind, and they will talk to you about advances in neural networks, gradient descent, and backwards propagation, things like that. But if you ask an economist, can you please tell me what's happening in AI? They won't have an image like this. They have an image like this. And economists think about AI as effectively a drop in the cost of prediction. Why does it matter? Like, why is this just a useful way to think about it? Because as soon as we convert this into a cost, then we can just bring in everything from your Economics 101 textbook to handle this thing like any other good. And so what happens when the cost of something falls? Downward sloping demand curves. The first thing is we use more of that thing. And so how do we use more prediction? In two ways. First, everywhere that we're already using prediction, we just use more of it. So for example, at banks that are already, have groups of people, data scientists, who are doing predictive analytics on things like fraud detection, now we can just take out those old tools and replace them with new, more sophisticated, higher fidelity predictions from AI. That's the first way. Then the second way that we start using more prediction is by taking things that we didn't used to think of as prediction and turning them into prediction. So just like we did with semiconductors and arithmetic, for example, let's say photography. There's enough people in this room who probably have no idea what that image on the left is. I just realized this. Okay, but there used to be a thing, photography used to be a chemistry problem. And so there's at least enough people in the room to verify what I'm saying isn't fiction, that we used to actually have photochemical film, and that you take pictures and then you take that canister to a place to develop it into pictures. But as arithmetic became cheaper and cheaper, we swapped out chemistry and replaced it with arithmetic. And so we started using arithmetic solutions to solve photography. And similarly, as prediction becomes cheaper, we start taking things that we didn't used to think of as prediction problems, like driving, and we turn them into prediction problems. And there's a whole bunch of those types of things that when we were doing Next early on, and so let's say a decade ago, if I would have asked a room of participants in the Next program, nobody would have characterized any of these things probably as prediction problems. And today, they're all prediction problems. And so just to give a couple of examples here, like that one on the top right, that's a company that I was on the board of. And effectively, this is a company that does machine intelligence embedded in mining systems. And so one of the tasks in mining is to measure what they call the fragmentation. So right from the moment you execute a blast with dynamite and blow up the rock, all through to when it's being picked up, sent to the crusher. After the crusher, it goes onto a conveyor belt, then it goes into more processing. All the way along, it matters what is the fragmentation of the rock. And so they would used to stop, for example, in this stage of the process, they would stop the conveyor belt, and a human would go in and measure like how much sand, how much small pebbles, how many bigger rocks, how many, and that would impact what they're going to do later in the blast. That would impact the crusher. That would impact a lot of things. Now there's just a camera that sits there. The camera sends a feed to the AI. AI predicts what an edge is. So like what's an edge, what's not an edge, and then effectively draws the outline of the rocks and then measures the rocks. And so that whole thing's being automated. Bottom right, inspection. Let's say in oil and gas, of course, there's lots of humans whose job is just to go and inspect and effectively predict if there's going to be a failure. And now, as you can imagine, we can just sensor up the thing with pressure sensors, visual sensors, cameras, radars, and so on, and have 24-hour, so much higher fidelity inspection rather than once a week or once a quarter. It's 24/7 inspection and doing early prediction of failure. So all these things are prediction. Okay. And so, and then the last thing, I won't spend a lot of time on it, but we talked about in prediction machines was, okay, so first of all, cost of prediction falls. Secondly, once prediction becomes cheaper, we use more of it, both in areas where we're already doing prediction, and then we convert new problems to prediction problems. And then third, and this is probably where the New York crowd spent most time following up with us, is on complements and substitutes, like particularly private equity and hedge funds. They were interested, okay, if prediction becomes cheap, what things will start becoming more valuable? Like what things should we start acquiring or investing in now in anticipation that their value will go up as the cost of prediction goes down? And so that was complements. Thanks. And so complements, basically substitutes, is when the cost of something goes down, the value of the substitutes also goes down because one substitutes for the other. So in this case, as the cost of machine prediction goes down, it drags down the value of human prediction. So human prediction becomes less valuable, but it increases the value of complements. So all the things that we use with prediction, and so I'm not going to spend time on it now, but things like inputs like data, human judgment, the actions that we take as a function of the predictions. So for example, like in that mining example, collecting the data of what we do once we take a fragmentation measurement, that becomes a complement and valuable. And all the instrumentation in order to collect the data, like the cameras and all that stuff, becomes more valuable. Okay. So that was fine. We published the book in 2018, and away we went. And I think a number of people found it useful. And then we started. Once you commit to a thing, like in a book, you commit to a set of ideas. Then you can't Then you have to reconcile when things show up that don't fit with the mental model that you presented in the book. And that's what started happening. We started, a lot of people started using the book, and various, large companies. The CEO of Workday bought 10,000 copies of prediction machines for everyone that worked at Workday. McKinsey started giving it to all their consultants and their customers, their clients. And then things started coming back to us where people would say, hey, this thing, how does this fit into the models that are here? And one thing that came up was we hosted this conference, and the Prime Minister was there, and he was talking about, they were announcing, and Julien is here, who leads the Scale AI, the AI supercluster. He was talking about superclusters. And he wasn't talking about just the AI, he was talking about the idea of superclusters in a number of different areas. AI was one of them. And a question came up, which is, where do we predict the first AI unicorn would appear in Canada? And so, and unicorns, of course, startups worth in excess of $1 billion. And so it wasn't very risky of us, and our view was, okay, it'll probably be Montreal or Toronto or maybe Edmonton. And the reason is that there are these superstars there, like Yoshua Bengio in Montreal and Jeff Hinton in Toronto. This was early in the AI wave. Rich Sutton in Edmonton, and they and there were Mila and Vector and Amy, like the big research institutions. Companies were pouring into those cities at that time. NVIDIA and Roche, Reuters into Toronto, Ericsson, Facebook, Microsoft into Montreal, Google DeepMind, Amazon, and so on into Edmonton. So it seemed like pretty obvious it'd be one of those places. How confident, they asked, are you in your prediction? We said, yeah, we're pretty confident. And why are you so confident? because we said, well, we're experts. We're experts, don't you know? And so, we wrote this book, and we've done these academic articles, and we serve on these panels and white papers and all the experty kind of things. And of course, we were wrong. And not only were we wrong, I would say we weren't even a little wrong. We were a lot wrong. A little wrong would have been, okay, it wasn't Edmonton, it was Calgary. It wasn't Toronto, it was Waterloo. That would have felt like, okay, we almost got it. But we were very wrong. The first unicorn didn't come from any of these places. Not even our second guesses. So where did it come from? And some of you know where it came from, but it was an unlikely place. Very few people would say, have guessed, certainly not the so-called experts, St. John's. And the reason that we missed this was because we had been seduced, I think like most people, into focusing on the supply side. So where was the supply of frontier AI coming from? It was coming from the research institutions. And that's why the corporations were all piling into they wanted to be right next door. And instead, what we completely missed, and I can't believe we missed it given that we're economists, and that, there's only two things we have to remember: supply and demand. And we only, we're focused on the supply side. And what we should have realized was that in the early wave of AI, the most immediate deploy would be where there was already well-structured demand. And it's not even hard to guess where the demand is, because all you have to do is pull out the Canada's 300 largest companies and see who is already doing predictive analytics. Who has the most data scientists already employed, because that's just where it's going to slip in most naturally. And if we would have even spent 10 minutes studying the demand side of this, we would have quickly realized, okay, let's just count data scientists. And we would have said, it's the banks. The banks will be the first area of the first customer, because they're already structured, where they're already doing a bunch of predictive analytics with their data scientists, and so it's surgical. They can just go in, pull out their old predictive analytics tools, and put in this new, more advanced AI or computational statistics. And that's what Verafin was doing. So at that time, you could go coast to coast in Canada. There was a half a dozen companies that were doing this kind of predictive analytics for banks, and that were starting to experiment with AI. And if we just looked at those cities, that would have been our answer. But we missed the demand side. So Verafin is not a fluke. Verafin, by the way, they were making software for fraud detection, sanction compliance, anti-money laundering, that kind of stuff. So our two mistakes is that we were over-indexed on the supply side. We were totally focused on the supply. We were getting mesmerized by all the labs that were producing kind of neat, cool, novel innovations in AI, and we were completely ignoring who was working on problems that would snap in easily on the customer side. And then the second thing that we were focused on, which is or that we missed, was we were focused on what companies could do. And we were ignoring, yes, but what would they do? And feels like I'm just playing sort of word games here, but this is a very big deal between what companies could do and what they will do. And I know that this is an easy audience to make that point for, because so many people here are entrepreneurs, and so you know the difference between what they could do. What they could do is buy your product. And in your mind, why wouldn't they? And yet it's still such a steep hill to climb for a variety of reasons. And that's what I'm going to dig into now. Okay, so that basically sets the stage for the new book. Is we had ignored the demand side, and we'd focused on the supply side, and we'd also been very focused on what can companies do instead of what will they do. So 2 years after Prediction Machines is out, we're getting back all this feedback. And as you recall, and even when Next set up Next AI, there was a view that AI was going to transform the world. And here we are today, at the end of 2022, and certainly there are some very valuable AI applications. But for the most part, I would say we don't feel like the world is being transformed by AI yet. Why? If I was going to offer you one image to keep in your mind as the image that represents this book and represents what we think is the next wave of AI, you're probably thinking, oh, maybe he's going to show us an image, like some artistic image created by Dali or one of the recent image generation, like generative AI thing. So it's not that. Some of you might think, oh, he's going to show us an image of somebody like one of the world's best AIs beating a grandmaster at chess or Go. No. You might think, oh, he's going to show us the AI that's in Elon Musk's humanoid robot Optimus, the control system for that, or the control system for Tesla. Nope. I think the image that is most useful to have in your mind as you think about, okay, there is another very big wave coming, it's this one. This is the image. Anybody who just want to weigh in on what's happening in this image? Now some of you have seen it before. Yes, please. A demographic wave? That could, but we're getting very simple here. This is just like what's happening in this particular picture. Yes, please.
It looks like they're being trained.
They're being trained, okay. Any other details to add on to that? Yes, please. They're being trained in transportation, okay. Anything else?
Someone signaling a pivot.
Signaling a pivot. You're back up in the macro strategy. That's probably true. Yep.
They're learning how to code.
Learning how to code? No. I don't know if maybe there's a glare on the screen. But what they are sitting there on their desks are maps. And these are people training to drive taxis in the City of London. In the City of London, you need to go to school for 3 years to drive a taxi. You have to learn what they call the knowledge. And there's a bunch of schools right in the city and some in the outskirts where you go to school for 3 years. And the first year you study maps. And the second year you get on a moped and you basically drive around London on a moped. And the third year is both maps and mopeds. And then at the end of the third year you get an exam. And the exam will be something like, it's 4 o'clock on a Thursday afternoon in November and your passenger wants to go from the Churchill War Rooms to the Royal Botanical Garden. What's the fastest route? And they have to know. And so, of course, today, you and I can just, fly into Heathrow, rent a car, flip open a phone, and even if you've never been to London, you can navigate that route from the Churchill War Room to the Royal Botanical Garden, as well as a taxi driver with the Navigational AI. Now, here's where this becomes interesting and where I think it's like this is the key to what's like this. If the first wave of AI came and it was like a small wave, the second one that's coming is a much bigger wave for the following reason. The AI that we use to predict the best route between A and B, we can call that a navigational AI. And the majority, like if a company came to, let's say a startup came into the next AI program, and they said, okay, we've invented this thing, and it does this prediction. Like let's imagine we wind back the tape, and let's say it's 2015, and someone showed up at Next AI, and they said, I've invented this AI. This is what it does. The easiest entry point, market entry point, would be, it would say, okay, this thing does predictions associated with routes. Who would probably want to buy it? And our brain would be embedded in the systems that exist. And we'd be looking for how to use this tool as a point solution to improve the productivity of the system. So the system would be, let's say, taxi companies. And so we'd say, well, you could take this tool and license it to taxi companies. And what that would do is it would improve the productivity of like the average and below average drivers. The best drivers probably just always, like they always know the best route. But the mediocre and the below medium driver probably doesn't always have the best route, and so this could be a productivity enhancer. And actually, when you ride taxis, if you're a taxi driver, there's two reasons. There's sort of two key predictions in your job. One is the navigational prediction, but the other one that, unless you've driven a taxi, you might not think about, is the prediction of where to go when you don't have a passenger. So it turns out that on average, taxi drivers spend half their time driving passengers and half their time looking for a passenger. So you can increase your productivity as a taxi driver if you can get good at finding passengers faster, spending less time with an empty cab. So it turned out that last month, a group of our colleagues at the National Bureau of Economic Research published a working paper on this. They spent a year and a half collecting data on exactly that from a few years ago when they had just introduced something called Navi AI, a navigational system for driving. And so they said, we're reporting in this paper taxi driving, and we're studying the impact of AI on productivity. Okay, so if you're an economist, this is like a dream come true. Everyone's been talking about AI. Finally, somebody's figured out how to measure productivity in one industrial setting. Taxi drivers are an ideal case to answer this question, is how does AI enhance productivity? A worker's individual productivity is easily measured by the length of time it takes to catch customers. Each driver works independently and has considerable discretion as to how they find their customers. Okay, so this is going to be a difference between the high productivity and low productivity drivers. How fast can they find a customer? The AI suggests routes based on predicted demand. So what the AI does is it predicts where it thinks a driver will most likely call next. And so it directs the driver to go, even though the person hasn't called yet, saying, I think someone is most likely to call in this neighborhood. And given where you are, this is the best place for you to direction for you to go when you're empty. Okay, this type of AI, which increases the accuracy of prediction tasks from the patterns of data using machine learning technology, is widely used in real business settings. Okay, so obviously they're studying this here in the taxi setting, but the same sort of general concept applies across. Importantly, the productivity gain is concentrated on low-skilled drivers. The impact on low-skilled drivers, where skill is defined by performance, is 7%. Okay, so here, this is their measure. Okay, so first of all, what they said is, hey, we found a 7% productivity lift, but it's not for everybody. It's 7% for if you are below the median, you get this boost. The impact on the high-skilled drivers above the median is nearly zero. So the experienced drivers, they already have a pretty good instinct of where to go to pick up a passenger, and they're right most of the time. It's the inexperienced ones who get a boost from the tool. As a result, the AI narrows the productivity gap between high and low skilled drivers by about 14%. Okay, so if this innovation had come into Next, and we had sort of thought, okay, what's the best way to bring this to market? And we said, okay, why don't we package it up as a tool that will sell to taxi cab companies, and we'll tell them this is going to give your lower skilled drivers a 7% productivity gain. It will reduce the gap between the top and the bottom by 14%. Nobody in this room would probably have ever heard of it. right? In other words, they probably would have, some cab companies would have bought it, some would not have. It would have been behind the curtains. Most passengers would never know it existed. That would have been the point solution. But the reason we picked this is there was also a system solution. And of course, it's a system solution that everybody in the room knows about. Think about this. You could not do Uber without this prediction. So in other words, imagine the very first time that a car pulled up with a novice, unskilled driver in an unmarked car and pulled up to your house and you got in and they didn't have a navigational AI. And you said, I'm going X. And then all of a sudden they pull out a map or they do whatever and they start looking. And you would have thought, okay, that was a good effort, but I'm going to stick with the professionals and ride in a taxi. Like, I'm not going to do that again. And furthermore, all the Uber drivers who are waiting for their ride, they don't all have a dispatcher that's telling them, this is the neighborhood you should go to while you wait. So this Uber would not have worked without the AI. But here's the thing. The AI was a piece of a puzzle that unlocked over $100 billion in underutilized CapEx. Think of all those cars that were sitting in people's driveways on the curbsides and their parkades that all of a sudden lit up. And what we all observed was a transformation to the transportation system, which is now global. And that $100 billion is only Uber drivers, about 5 million Uber drivers in the US. Let's say the average value of a car is 30 grand. And that's just for Uber and just the US. So think about what that unlocked and the system level change. And in our view, as we started poking around from manufacturing to retail to drug discovery, through right down the path, you name it, most of what we've seen have been what we would view as important, but still economically marginal point solutions. Making one of Canada's banks slightly more efficient at fraud detection and anti-money laundering. It's very good. It's good for both sides of the market. It's good for them. It's good for the customer. But it's not transformational. But you can start imagining that as you can automate these things, Fairly AI is here, they're automating compliance. And when you think of, okay, that right now their solution is, it's a very narrow point solution. Somebody's going to roll that up and do a system-wide new way of managing transactions. We see that in various attempts at a full-stack fintech solution. So I think, the image to have in your head is, in terms of what's coming, is I find these two images, there's a whole bunch of things in these two images side by side. Some of them you will find off-putting, but I think they capture what's happened. And if you read the story or watch the Netflix Super Pumped, the story of Uber, one of the things that's so fascinating is why did this system happen and all the the fintech and the health tech and the education tech, why are those ones haven't happened yet? And Travis, whether you like him or not, railroaded over all these regulatory barriers. My co-authors, Joshua Gans, Avi Goldfarb, as well as a professor named Catherine Tucker at MIT, we host every year a conference of some of the top economists around the world who are working on AI. Come to Toronto for a couple of days. This year, the second day we devoted to health and AI. And I would call that day both inspiring and depressing. It was inspiring because people were reporting on all these AI applications in healthcare, most of it in diagnostics, where AIs were so far outperforming docs Like AI is better able to read medical images than radiologists. AI is better able to read pathology slides. AI is better to predict attempted suicides than mental health experts. Like just one area after the other, cheap and fast. So you can imagine all these cost pressures on the health system, and you think, like, this is amazing that we can reduce the cost, increase accessibility. And it was depressing because almost none of these have been deployed because of regulatory barriers and the structural inertia in the hospitals and insurance systems. And so you could say to yourself, you know, what we need is about 100 more Travis Kalanick's. Even though some people find parts of, you know, how he operated the company offensive, that from a social welfare perspective, it's hard to deny that the world isn't better off with a bunch of previously way underutilized assets now being utilized much more productively. Okay, that's point number one. Don't worry, the other 2 points are quicker. Okay, point number two, the between times. Why does it take so long? So why have we seen this system level change in transportation, and so far we have seen very little other system level change. Almost everything else has been point solutions. We term this thing the between times. The between times is the time between when we first get proof of concept that the technology works to when it's in wide-scale deploy. And so that time in between, we call it between times. For all the entrepreneurs in the room, you can call that, like, that's the time where you are, you know, running out of money all the time. So there's a lot of times where people have been, over the last 6 or 7 years, comparing AI to electricity. They say that AI will be ubiquitous like electricity. It will be everywhere. And this language is very common. So I'm going to spend a few minutes talking about electricity. Electricity, invented in the late 1800s, and for 20 years, the first 20 years after the demonstration of electricity and how it worked, the adoption rate was very low. So let's say factories in the US, less than 3%. So think about, imagine the early pioneers showing up to a program like Next. And they said, okay, we've got this new technology, it's called electricity. What's the value prop? And the value proposition would be, at that time, effectively that it saves fuel costs. It's a slightly lower cost of providing energy. And the reason for that is, let's say, steam or let's say oil lamps. In the case of, let's say, steam, that there's a lot of energy loss, like friction, associated with, you know, bringing the power into the factory. But if you're a factory owner and you've already set up your factory, you're not going to pull out all your gear just so you can pull in some electricity and save a marginal amount on the operational costs when you've already made this very significant infrastructure investment. So the power would typically, I don't know if this got a laser, but you can see, like, at the top of this image, the steel shafts with the wheels on them at the top. You know, that's effectively how you bring the power, and those things would turn. And so you'd lose, of course, the friction there. And a couple of things happened. As the first few factories, the new ones that were built, so we're not going to pull out these systems to bring electricity into existing factories. But as they would build new ones, a few early entrepreneurs would experiment with electricity. And then they realized, wait a minute, if we use this electricity, we don't need, you see all the heavy bracing to hold up these big steel rods. We don't need those anymore. So the design of the factory can be much more lightweight construction because we don't have to hold up the big heavy steel shafts. Secondly, they realized that because those shafts could only be a certain length, that they would, in order to get all the machinery in the factory, they would have to build multi-story factories. But now, because they weren't constrained by the length of the shaft, they could effectively make single-story factories. Again, cheaper construction. Once they had single-story factories, they said, okay, now everything's on one level. We can completely redesign how we lay out the machines and the workflow, make a much more productive workflow than when they had to build when it was designed vertically. Furthermore, before, because everything was hooked up to the same power source, when one machine went down, the whole place would stop. Now, because each one had its own power line coming in, if one machine went down, and in those days they went down quite frequently, when one machine went down, everything else could keep operating. And so after they, 10 or 20 years into this, they started realizing, wait a minute, the value prop from electricity is not really lower fuel costs. That's just the tip of the iceberg. When you use electricity, the real value is you can decouple the power source from the machine. And as soon as you can decouple those, you can get all these other productivity benefits. And so it led to a system-level redesign where all these things were improved. So if you take that first wave of adoption and you just extrapolate it, this is what we would have expected as the second wave. But instead what happened is as everyone started to learn that the real value proposition wasn't lower fuel costs, it was the ability to redesign the system. Instead, they got this. And this was the real productivity lift and adoption rate. Okay, now with AI, we're not decoupling the power source from the machine. What we are doing is we're decoupling prediction and judgment. Okay, so prediction and judgment, we don't think of this explicitly, but we are executing these two functions every time we make a decision. Small decisions and big decisions. And so another key theme in the book is the reason that we have the foundations for doing a system redesign is because AI is allowing us to decouple two of the most important ingredients of the most valuable thing that we do, which is decision making. Okay, big decision, little decision, we are making decisions all the time, and every decision requires these two things, whether you recognize it or not. Like most of the time we don't. It's not consciously, we're distinguishing. I'm going to take you through an example in a moment, and you'll see what I mean. But the essence of what I'm going to describe to you is AI is going to allow us to decouple the prediction from the judgment, and it's the decoupling that's going to, like once you understand what it means to decouple prediction from judgment, then you start realizing how you can redesign systems. And it's right across the board. I spent last weekend at an international security forum. The US Secretary of Defense, Lloyd Austin, was there. Our own Minister of Defense, Anita Anand, was there. There was a set of people, and what we were talking about was how do we redesign the defense system in a war, and there's a set of people that are sort of very worried about AI because they are talking about AIs and autonomous drones and like AIs making kill decisions. Said no AI has ever made a kill decision. Only humans can make decisions because only humans have judgment. The machine does the prediction, but nothing is triggered until there is a judgment. I'm going to explain that in a second. But it's very important because there were a whole panel of people in the session before mine where everyone was using the language of machines making decisions because they had AI. Completely false. No machine makes a decision. We can give the illusion of a machine making a decision because when we separate prediction and judgment, we can decouple the action from the judgment in time and space. So you can have someone in Washington deploying their judgment, putting into code, and putting the code into a drone, and then it looks like the machine's making a decision, but they're not. They're executing on the code that was the judgment that was created by the person who put it into the software. So a drone is not making a decision any more than a landmine is making a decision when it goes off. Okay, so this is going to be important because right now we are in a world and I suspect this will get accentuated because of the shaky market conditions and the macroeconomics. Companies are backing off of AI. A recent survey of executives, 3,000 companies that had all made some investment in some spend in AI, they said only 10% of those said that they got a return on their investment. So 90% of the companies who spent money on AI felt they did not yet see a return on that investment. And so that leads to headlines like this. And so what this is setting up is, and I think, a great opportunity for entrepreneurs, because right when some of the established enterprise companies are backing away is the time where I think we can lean in to pursue opportunities. So to get down here at the core, decision theory. Decision theory is, you can think of it as has two elements. One is assigning probabilities to various factors and assigning numerical consequences to the outcome. Okay, so some of you have seen this before, what I'm going to show now. Think of the decision of taking an umbrella. So you're looking outside, it's overcast, there's some clouds, and you're deciding, should I take an umbrella or should I not? Seems like a simple decision, but it's exactly the same structure as a trillion-dollar industry, which is insurance. Okay, this is what everything I'm telling you is effectively insurance, but I use umbrellas because it's simpler. So you're making a decision whether to take umbrella or not take umbrella. You can think of buy insurance or not buy insurance, and to protect against the bad event. And so if you take the umbrella, then you're dry. It doesn't matter if it rains or not. And if you don't take the umbrella, then you might get wet, but you don't have the burden of having to carry around an umbrella. There's uncertainty. Okay, this is important because this is where AI comes in all the time. AI is a tool to address decision-making under uncertainty. And so a key is to find where the uncertainty is. And often we have hidden uncertainty so cleverly that we forget it was there in the first place. I was just visiting a massive warehouse owned by Canadian Tire. It's beautiful. It's highly automated. It's got all this stuff. Warehouses are a monument to uncertainty. They only exist because of uncertainty. If we knew exactly what demand was and we knew exactly our supply chain, then we wouldn't need the warehouse. So it's beautiful, but it is only there because we have uncertainty. Okay, outcome is wet or dry. We make a prediction that's in the pink of how likely is it to rain, and then the outcome, that the stuff in the blue, that's judgment. Okay, so the machine, the AI does the pink, humans do the blue. And then we take the probability times the outcome and we get to the so-called expected outcome. Don't worry about the arithmetic, it's in the book, but the point here is that we are estimating what we call the expected outcome of taking the umbrella and not taking the umbrella. And in order to achieve that, we have to come up with the blue numbers. Humans do that. And if I ask a room of humans, I'd say, okay, look, if you look outside and it's like slightly overcast, some clouds, who would take an umbrella? Just show of hands. Who would take an umbrella? Okay, 1, 2, 3, 4, 5, 6, 7, 8, maybe 9, 10 people. So everyone had the same information. 10 people took it. Let's say 50 did not. That's because people have different values for the blue, the judgment. Some people it's like a higher cost to getting wet. Other people don't care. The prediction is what the weather station is making. A lot of them now using AI, taking all the atmospheric data and other data and using that to predict the likelihood of rain. Okay. So, but the point here is that the reason I just gave that example is I wanted to be clear, when we talk about prediction and judgment, these are not abstract concepts. They are very, they can be very precisely defined. And even though when you walk outside and you grab your umbrella, you're not explicitly thinking, well, what's my prediction of rain and what's my judgment of the, it's baked in. The bigger the decision, the more likely you are to make that a bit more explicit. But when you're building an AI, you can make these things very explicit. You have to. So, for example, when we were with Anita, the defense minister, this weekend, the key is how if, let's say, a drone is deciding whether to fire on a target, how sure does it have to be? What's the level of confidence and the confidence intervals that need to be in order to pull the trigger? And then the judgment is, what's the cost of a mistake? So if we're going after a target that is expected to be very dangerous, we might be willing to have a slightly larger margin of error than if the target is considered less of a threat. Now, nobody wants to make those explicit calls because they all sound horrible. But of course, some human is doing it. When it's not a drone, it's a person, and they're doing the same thing. But it's less explicit. Now you can have a committee and everyone agreeing how, what the costs and benefits are of taking these actions. Okay, so decoupling. Last point here is new systems. So we use this idea of decoupling to go right back to the drawing board and say, okay, if we were going to design a new healthcare system, a new education system, a new manufacturing system, a new distribution system, how would we do it if we could decouple prediction and judgment and we had a super high fidelity prediction machine, much higher than what we have in our brains? So the way to think about this is that every organization, company, government is an optimization machine. Everything has been optimized to most effectively achieve whatever it's supposed to achieve in a pre-AI world. Now we roll in and we bring in this new technology and we try and jam it into a system that's been designed for a world that didn't have that capability. So for example, when I meet companies that are like AI companies that are building a point solution tool for a distribution, let's say they want to sell to distribution companies. They look at the system as it was designed and say, okay, how can I put in my point solution to make it slightly more productive, like this let's say, warehouse. As opposed to, if I was going to build a new warehouse, how would I design it from the ground up in a world where we have this high fidelity prediction capability? So I'll just give a couple of examples and then wrap up. In the insurance industry, imagine going to the doctor and you go in, let's say, for an annual checkup, and the doctor checks you up and says, ooh, that doesn't look too good. I think you're probably going to get very, very sick in the next 18 to 24 months. And then said, thanks for coming by. I'll see you next year at your checkup. You say, well, wait a minute, doc. Aren't you going to tell me what's the matter and what can I do to get better? And the doctor says, no. I'll just see you next year. Like, you would think that's crazy. Like, the doctor just diagnosed me. They know something is likely the matter. Why won't they tell me? That sounds absurd, and all of us think about that and think there's no way a doctor would ever do that. But that's what the insurance industry does all the time. So you and I might go and apply for, let's say, insurance on our home, and my premium might be 20% more than yours. And the reason is because the insurance company has made a prediction that I'm more likely to file a claim. Yeah, the insurance companies are basically claim prediction machines. So they predict the likelihood of a claim, and that's how they set your premium. And furthermore, they are now getting so sophisticated that not only are they predicting the likelihood of a claim, they can predict what kind of claim. That because of your type of house and your type of neighborhood and your type of climate, you're more likely to have, let's say, water non-weather. Water non-weather claim is like a leaky pipe in your basement. Or you're more likely to have an electrical fire claim. So they can predict down to that level of specificity. But you don't know that. You don't know what they're predicting. All you do is you get your premium. Now let's say these types of sensors show up. You're watching late night TV and an ad comes up for a sensor that does early leak detection. And it's $300. And you're watching and you think, I wonder if it's worth it. Should I get it? I don't know. Because you and I, even though it's our home, we don't actually know if it's worth it for us to spend the $300 to buy that thing for our home. But our insurance company knows. They know whether the return on paying $300 for an early detection of a leaky pipe in your basement is worth it for your home or not. But they're not in that business. They have been designed in a pre-AI world. And so they basically do their mode of modus operandi is two things. One is pooling of risk. So rather than each of us having our homes and if something goes wrong, we're exposed to catastrophic risk, they pool the risk so that our risk is shared across all the homes, so no one home is overexposed. And then they transfer the risk. They pool it and then transfer it. So they say, okay, we'll take the risk, you pay us the premium, and we'll carry the risk. So they pool it and they transfer it. But they do not reduce it. So the risk hasn't changed at all, it's just moved around. But they have the ability to actually reduce the risk because they know that for this home, and this home, it's worth it for you to buy the 300 thing because the expected cost of a claim for you is much higher. For the other homes, it's not worth it for you to buy the water sensor. But you should buy the early electrical fire detection system. So then when we go and meet with home insurance companies, the first thing we get is the agent saying, well, why would we want to do this? Because if we do this, we sell this stuff, this will cost us money if we, for example, let's say we were to subsidize and buy the device. It would just cost us money. And I say, yeah, but you can get more customers because you can reduce your premium, and by reduced premium, you can attract more customers. And they say, but why would we want to reduce our premium? That's how, the agents are rewarded as a function of the premiums. Last thing they want to do is cannibalize their premiums by selling people devices that's going to reduce their risk. The system has been optimized for a pre-AI world. And so that's an industry. And of course, there are insurance companies that are experimenting with selling various early detection devices. But this is still in the very early days. And I'm not even sure whether any of the incumbents will get there or whether it will end up just being a startup. A startup who has nothing to lose, has no legacy, and can redesign insurance from the ground up. In car insurance, it's probably not surprising to you who's already doing this. A lot of car insurance is still, like if you're an 18-year-old boy, you pay a higher premium than a 40-year-old woman because you're male and you're young. And that's the level of granularity of predicting risk. Whereas Elon is doing it as, okay, I know how hard you brake, I know how aggressively you turn left, I know how much you tailgate. He gets it, he's got it down to these 5 measures, the ones on the screen. And furthermore, not only has he got a much higher fidelity thing of risk, he tells you your score every month. So you can see your score and you can say, wow, my score is 20 points higher because I'm taking, I'm always tailgating. If I can just reduce that, my score will go down next month and my premiums go down. So you can reduce your risk and see how your actions reduce your risk. It's hard to imagine a world where once this permeates, that anyone doesn't do some version of this. In education, I work in an industry, I teach in an MBA program. People pay $100,000 a year to come do an MBA. You can have someone who comes from a philosophy degree and someone who did an undergraduate in accounting. They both show up to do an MBA and they both have to do exactly the same classes. It makes no sense. They have very different levels of education for, let's say the topics in a business school, but we have a system that is designed pre-AI. It's mass education. And so this is an industry that is just ripe for a complete overhaul. What we've seen is a bunch of point solutions. People have tried point solutions of, well, what if I try, if I add this tool or if I add that tool to the existing system? And there have been tiny improvements, but it's still pretty much the same as it was 25 years ago. This needs a system level overhaul. Medicine is I've already spoken about it, but anyone who's been in a hospital or gone to see your doc I don't need to explain how broken that is. And then retail. I think that I'll sort of just conclude with one last point on metaverse, and then we'll have a few minutes for questions. This is the area that I've gotten myself very interested in recently. So metaverse, most people probably know what it is, but I'm focused on the part that is 3D real-time rendered worlds. And I know at the moment it's kind of being chastised in the press because it's how it's characterized by Facebook or Meta. But I think there are extremely valuable enterprise applications, and it's actually good right now that there's that because it leaves room for entrepreneurs to come in while everyone else is running for the hills. It's a good time to get in. The characterization, without going through all the definitions of metaverse, I think the way it's described, even though it's fiction in Ready Player One, it's a good description, which is you enter the world through a headset and you can interact with the world and have some haptics like with the glove. Since summer, so I think most of you, like if those of you who are in Next, I saw you in the summer program, the ones who are in the most recent year. This has all happened since we last met. McKinsey's put out a report estimating the value of metaverse as $5 trillion by 2030. So have like BCG, Bain, Deloitte, PwC, all of them in the last, since September. They've started categorizing what some of the large companies are doing in terms of their early experiences in metaverse. I won't go through this, but they're explaining digital twinning is where a lot of this is starting. Starts with creating industrial, and this I'm focused here on enterprise, not like games, but enterprise solutions and digital twins, creating a 3D model of the world that you are, environment you're working in, as a starting place. Now, what's all this got to do with AI? Three things. First is the data in metaverse is unprecedented. Okay, so everyone who's been collecting data for AI companies, for AI tools, wait till you try doing this in metaverse, because everything is digital. So think of the most powerful AIs in the world, like Google, Baidu, Facebook, Netflix, YouTube, and stuff. Let's say YouTube. If you're watching YouTube, the only time that they are getting data from you are the instances where your finger touches the screen, like turn up the volume, pause, play, go to the next video. At that moment that you touch the screen, it's getting a bit of data from you. And after you touch the screen a handful of times, it can start making predictions, saying, okay, I think this is probably male, I think this person's probably between 30 and 45, I think this person likes this genre of videos. It starts making predictions. But it doesn't know if you're watching YouTube, if you're sitting on the bus, if you're at home on the couch, if you're having lunch, if you're listening to music, it doesn't know any of those things. But if you put on the headset and now you are controlling an avatar that's walking through a factory floor or wherever, it collects everything and knows where you go, what you touch, your gestures, what you say, what you look at, everything. So the data for training AIs, multimodal data, is completely different level. Second thing is you can do a lot more experimentation. So I think the image got deleted here, but there is a great example of this. McKinsey was working with the sailing team, the New Zealand sailing team for America's Cup. And what they did was they created a digital twin of the boat and the sailboat, and then they started doing all sorts of design innovations. And then, and other countries were doing the same thing, other teams. But here's where the difference was. Every time they made a design change, they would then bring in the New Zealand sailing team and say, okay, now try sailing this boat in simulation. And so the team would come there and they'd be sailing, and they would say, okay, with this new design, we need to change the way we sail a little bit, and they would see, can we get a faster time? So they would do a very fast iteration on the design, and then they'd have to wait for the sailing team to come in and sail. Then they said, well, what if we build AIs to replace the sailing team? So then we can do a change in the design, and then the AIs can sail it. And then do another change in design and have the AI sail, and we can do a much faster iteration. And so that's what they did. And then when they would get to what looked like an optimal design, then they would bring in the human sailors, and they would have the AIs train them, say, okay, this is how they figured out how best to sail this new design of a boat. And then they would sail in simulation, and then they would actually build the boat and sail the boat. And they won the America's Cup after that cycle. So the point here is that in these 3D real-time simulations, it's an environment where AIs can have significant acceleration of innovation. Last thing here is, if I were to ask you to imagine, like say, swimming up to this glass and taking a drink, everybody here can do that. And you can imagine what it would feel like to wrap your hands around the conical glass and bring it to your lips. And the reason is that even though there's just a two-dimensional set of pixels, you look at that, and then your brain predicts the missing data that transform these 2 dimensions into a 3-dimensional model that's in your brain. And that's why you can imagine what it would feel like, because you've got a 3D model in your brain of what that 2D representation is. We can do the same with AI. We can do the same thing where we take this and we predict the missing data and turn it into a 3D model. And of course, you can imagine with the recent innovations in generative AI, we can do it even with a text string. We can just to type out a sentence that says, a conical glass on a deck near a pool, and then generate the 3D model. So in other words, there's a lot of room for AI innovation here. This is where I'm focused. If anyone's interested in this area, we've started a new lab here and raised funding. And we've got a core team building. So if this is something that you're interested in, happy to talk to you about it. We're both on the technical side. So the key roles are full stack software engineers, AI engineers, and VR engineers and artists. And then on the business side, there's a set of companies that we're building around this. If you're interested on the business side, come and talk to me as well. Okay, so I think we have about 5 or 10 minutes for questions. Yeah, point. Anyone have a question? Carl. And Carl, maybe you could say a couple sentences about your company so that if people are looking for help in AI, you guys...
Sure thing. So I'm Carl Martin, CTO of Integrate.ai. We make data science and machine learning tooling to work on sensitive data. So this is in healthcare and financial services, collaboration across organizations where the data should not be moved, it has high regulatory compliance requirements. We provide the tooling to make that work. Question, when we think about decision making, naturally accountability to decisions is a big question. And I think the systems of accountability, typically we think of holding humans accountable, and holding new types of systems accountable, I think, is a challenge. And this is a big one in healthcare, right? Which is, we normally hold doctors accountable to make decisions. So when you think about separating prediction from judgment, like it seems, how do you have any thoughts on how systems of accountability can adapt to that? Because I think it's one of the big barriers to adoption, which is there's resistance. How do we hold these things accountable? So in this sort of model of that separation of prediction and judgment, how do you see accountability evolving?
Yeah, it's a great question. So an example that I took out of here, just to shorten the presentation a bit, was when in his rookie year when Michael Jordan injured his foot, and then he wanted in the later part of the season to get back in the game, and the docs, the owners of the Bulls, asked the doc, like, what's the likelihood of another injury? And the doc said, like 10%. And then he said, well, what would happen if he got injured again? And the doc said it would probably end his career. And so both the owner and so Jerry and Michael both heard that. And Michael said, okay, great, like let me on to play. And Jerry said, are you kidding? Like, didn't you hear what he said? And what was interesting about that is that was a medical decision where prediction and judgment had been decoupled. The docs had done the prediction, 10% chance of a career-ending injury. And now they were both applying their judgment. And so I think ultimately the regulators will realize that going to these systems are going to be an improvement on transparency, because right now docs are making decisions all the time. And that's why we have an industry of second opinions, because even though they all went to medical school, some will decide it's red and some will decide it's blue. And we have a hard time going in and understanding, well, why do you say it's red and you say it's blue? Given that you're both docs, you're both supposed to be experts in this field. And is it because you have a different prediction of like what the outcome possibilities are like, or is it because you have the same prediction but you're applying different values to the different outcomes? So these systems will require those to be explicit rather than implicit. And then when we get a bad outcome, we can go back and say, well, was that because of a bad prediction, or was it because of the weights that we put on these things? Like, in other words, is this bad outcome something that seems reasonable given the probability distribution we had for this thing? In which case, it's a judgment problem. And so I think that once the regulators start understanding how this works, they'll realize we can get much more transparency, not less, because people are going to be forced to make these judgments explicit.
Something I'm wondering is, as founders, our go-to
principle is try a system point method of getting into the market. What is that new shift as we're looking at a systemic version of approaching our innovation within the market?
Yeah, it's a good question. I think it's much easier to raise money for a point solution because it's generally simpler and the path to market is more clear, because you say, look, this is how the system works. I can fit my thing in here. And so the system solutions are a bigger swing. And at some level, I don't want to say this as a general thing, but intuitively, this feels like it's probably right, is if you're a first-time entrepreneur, probably just try and knock out a point solution. If you've done one already and you've had some success, and you've got some street credibility, there's, I think, on average, a much bigger prize for the systems. And I think investors will be more willing to take the chance once you've kind of exercised your chops and shown that you can just deliver on something.
Thank you so much. This has been really enlightening. I really, the first book was amazing, but the second book, I can't wait to dive in. My name is Alan. I'm with a company called Metaverse. We're a proud Next alumni, so thank you for Next for having us. And it's the question I have is really around, if you were to systemically recreate a new education system from the ground up as a personal, private education for an individual with only the individual's best interests at heart, not trying to advertise them things, not trying to sell them more things to watch on Netflix, but using these powerful tools to recreate systemically from the ground up a new education.
Right, so this is a big one. As I won't go through the whole thing, but let me just start with a concept, which is I would, first of all, have explicit objectives. So as the learner comes in, what are you here to achieve? Because effectively, we can optimize for you differently from someone else if your objective is different. So like some people are there to learn a particular topic. They don't care about the accreditation. Some are there because they want the accreditation. And so they'll I'll learn whatever I have to learn to get the accreditation. Others are there for, I don't really know what I'm here to learn. I don't have a specific thing. I want to just generally, advance myself and build a social network. Like a lot of MBA people are there partly just to build their network. So thing number one is clarify the objective, and different people will get different paths. Secondly, personalize. Right now, because we have an education system that bundles together learning and network building, that everyone is sort of dragged along at the same pace. And then you say to someone, well, you could go do Khan Academy and just learn on your own really fast, and you're not held back by people who let's say, don't know the subject area as well as you. But then they have no social. So the way that you can imagine redesigning this is a system that decouples the learning part from the social part, that still has those parts. Like unlike Khan Academy and all of the online do-it-yourself learning, they're completely missing the social part. Or at least largely. And so redesign, re-put those things in, but I would say the core of the educational part would be enable personalization. And so at every step of the learning journey, you make a prediction, what's the next most relevant thing for this person to learn? So they're not wasting their time on things, or it gives them extra help on areas where they need it, but without decoupling all that, without throwing away all the other elements of learning, like the social part. I think we have time for one more.
Over here. Hi, Jay. I'm working for Drug Bank right now, and we're a drug information tech company that powers other AI-enabled biotech or pharma companies that are doing drug discovery. And you mentioned that policy is one of the things that's prohibiting a lot of the systemic change in healthcare. So what do you think needs to happen in policy to allow customers of ours to kind of make that change? And is AI behind some of that policy change as well?
I don't think AI is behind the policy change. I think the policy change is going to come from people. So that one's easy. It also matters where in the value chain. So for example, one of the graduates from Next, Abe Heifetz, was early in using AI for drug discovery, using AI to predict which molecule will most effectively bind with which protein. That doesn't require any regulatory oversight, because you can do that prediction and come up with your target and go through the process, and then once you've got something, take it through the regular FDA approval process. So it depends where in the cycle you are of how much regulatory barriers you have for introducing a tool like this. If you're in a place, let's say an AI in a medical device, and especially one that if it learns from use, there's a lot of complications there. And other than just educating the regulators, I'm spending a bit of time on this right now on the insurance side, which is also very regulated. And it is a very slow and painful process. Because that's both state and federal level regulation, and it crosses a number of different domains, and so each body has to kind of be brought along. And so what we're finding is, to the extent that we can create small sandboxes where they say, okay, you can experiment with this under these parameters in these two states, and just do this and this, and then report back everything, like over-report back, is the approach that we're taking, so that they feel like we're not some swashbucklers who are coming in and ignoring the rules, and that they're learning along the way, and so it's slow and tedious, but it feels like of all the things we tried, that's the one that's having the most success so far.